Our next topic, we're going to talk about a lot of things oriented towards the differences between Apex as a multi-tenant cloud computing language compared to traditional on-premise oriented languages. So what we're going to be looking at is we're going to talk about some of the unique syntax that we use for declaring classes, methods, and variables. We're going to talk about the transactional nature of the platform and governors. We're going to talk about some of the standard libraries that come in Apex. And we'll talk about handling and viewing errors. I'll show you the developer console. And then we'll talk about record sharing. We'll talk about how in Apex we can control access or the way that we access the database. So if we take a look here at some of the similarities that exist between a class that is declared in Apex versus a class that is declared in another language, there's a tremendous amount of similarity in terms of the base syntax that we use. So things like using the extends keyword, using the class keyword, or having access modifiers, so on and so forth. There are differences regarding the different access modifiers that we have in Apex. The way that we are able to override a method or make a class extensible. We'll talk about exception handling, we'll talk about the memory lifecycle, and then governor limits. So, Apex classes. So here's a lot of the keywords that go into declaring a class. You'll notice that we have a few access modifiers here: private, public, global. I'll talk about those in a second. Some of these probably look familiar, virtual and abstract, but with sharing and without sharing, we'll talk about those in a bit. We then declare our class name. It either implements an interface or many interfaces or extends a class. So when we're creating a new class, there's a number of different ways that we can do that. You can go into the setup menu and create a new class from Develop Apex Classes. I'll show you that in a second. You can go into the developer console, or in our Force.com IDE, we can right-click anywhere within our project and then select New Apex Class. One of the key differences between Apex and other languages is that in Apex, all classes are final and all methods are final by default. They're implicitly final. So if you want to create a superclass that you would ultimately want to extend later, you would need to apply the virtual keyword to that class definition. An abstract class must be extended, so that kind of goes without saying. So the same thing applies to the virtual keyword when we're applying it to methods. If you declare a method, it will be implicitly final. You must apply the virtual keyword to that method in order to later override it. And when you override it, you also have to apply the override keyword in your subclass to indicate that you are overriding that method in the parent. So a bit of a reversal probably compared to what you're used to, possibly with other languages. So here we have our virtual class. One thing to point out, there is a super keyword and there is a this keyword. And here what we're able to do is to call the parent using the super, and in this case we're just dumping out our own unique message here. Alright, there are three, when we're talking about a class, there are three access modifiers that we can apply to those classes: private, public, and global. And I'll talk about this in a second, but the way I like to think of this is that there are 2 use cases for private and there are 5 use cases for global. Otherwise, you're always going to be using the public access modifier on your classes. In general, global is the most visible, public is the next most visible, and private is the least. Now, with class access modifiers, the definition is anything that is declared as public is only viewable within its own namespace. Namespaces, unique namespaces, are utilized by AppExchange packages solely. Unlike in some other language where you create a package And you now have this unique namespace in your code set or your library. Apex doesn't work that way. In Apex, we reserve that namespace functionality for applications that are published to the AppExchange. You create what's called a managed package, and you essentially register that unique namespace so that when you upload your classes, you know that you're guaranteed not to have a naming conflict. But if you're just a customer who's working within their own org and creating your own unique classes and methods, you will not be getting your own unique namespaces for those situations. Now, the reason that we have global in addition to public, remember I said that public is limited with respect to visibility to your own namespace. Global is utilized for the purpose of AppExchange vendors. They can create a global class. They can upload it into the AppExchange as a managed package, and the customers that utilize it can install that Apex class, that global class, into their org. In that use case, the customer can access that global class in their package. And so maybe they want to call a method or instantiate an instance of that object. Because it is global, their customers now have the ability to access that. Otherwise, if they would have declared that class public, their customers would not be able to see that class. So here are the use cases for utilizing global and utilizing private. If you're going to create some batch Apex, then it must be contained within a global class. If you're creating an inbound email service or a web service, it must be contained within a global class. Same thing goes for scheduled Apex. And the final use case has to do with what I was describing with respect to AppExchange applications. You want your customers to be able to call your code directly via the interfaces that you provide them via your global classes. There are two use cases for private. The first is where you have an inner class and you want that inner class to be only accessible within the containing outer class. Then we can apply private to the inner class. The second use case is it's not necessarily deprecated, but it's no longer necessary. It used to be a requirement that we would have to apply private to our test classes, but these days we can apply public to our test classes. So you can have a private outer class as long as it is a test class. And so finally, when would we want to utilize the public access modifier? Well, if it's not one of those 5 use cases for global or one of the 2 use cases for private, then we're always going to be applying public to our classes. So let's talk about the access modifiers for the members of those classes, the variables and the methods. We actually have 4 of these in this case. There's global, public, protected, and private. Private means that this member variable or member method is only visible within the containing class. Protected means it's visible within a class or from any subclass. Public means it's visible from anywhere within your org. And global, once again, only applicable to the AppExchange from the standpoint of visibility, means that it is accessible by your customers after they've installed it into their orgs. There are certain things like methods in an email service where the method that is going to be called upon an email being received, that needs to be marked as global. So there are definitely some unique use cases where global is required, where you're utilizing Apex. But from a conditional standpoint, global is really only used conditionally by AppExchange vendors. Transactions and governors. With the possible exception of a scheduled Apex job, at the end of the day, Salesforce receives an HTTP request of some sort, whether it's via browser or an API call. And it kicks off a sequence of events up on the application server to handle that request. Ultimately, we're going to execute some Apex code during that request, and that's going to mark the beginning of our transaction. Actually, it goes beyond Apex in the sense that we might have some other things that are occurring, things like workflow and so on. But that is a synchronous request coming into Salesforce. And what we do is we monitor that and we track that as a single transaction, a single synchronous transaction. So let's say that we have a custom web service defined. And the way that we do that is we define that custom web service as a method in Apex. And so let's say that our custom web service is going to call a method defined within some other class. And in that method, we perform a DML operation that's going to write some records to the database. And let's say that we have an Apex trigger that gets fired off as a part of that DML operation. In that case, all of these different events are being tracked from a database standpoint as a single transaction. So if I have an uncaught exception anywhere within that sequence, maybe it's within the original web service method, maybe it's within the trigger, everything is going to get rolled back in the case of that uncaught exception. So you have all these different database operations. We mark them as a single transaction. We roll them back based on that situation occurring. There's also some memory implications to this. In Apex, when we receive that request and we're kicking off the transaction, the platform will allocate heap space in order to handle that request. All the memory, all the heap space which is generated during that transaction is created. And then at the end of the transaction, it's going to be garbage collected. So within that context, things like a static variable don't behave in the same way that you're used to when you're programming in a language like C# or Java and you're running your code on a virtual machine. In the case of a static variable, let's say if we're talking about a JVM, that single static variable exists when that class gets loaded through the class loader. There's now a single copy of that variable within the VM that multiple requests would be able to access. It doesn't work that way within Apex. If you create a static variable, its life cycle is limited to the transaction. So there's not this concept of this universal static variable out there in memory which multiple transactions can access. Every time that transaction kicks off, we're going to reinitialize whatever that static variable is. Okay, governors. So because Salesforce is running on a true multi-tenant platform, one of the things that we need to do is we need to ensure that different customers are not overutilizing system resources because they've written inefficient code. And for that reason, we have this set of rules, which we call the governors, which say that you can't overutilize those system resources during one of these synchronous transactions. Because if you think about it, we have this multi-tenant system. If a single transaction is overutilizing those resources, you're not just slowing your own application down, you're possibly slowing down the requests coming from other customers who are using that same system. We can see this in the real world. If you think about something like international fishing rules, there are treaties among countries to not overfish in the ocean. And the reason is that if everyone went out and consumed as much as they could, none of that resource would be left for anyone. So it's kind of the same concept as we're working in the multi-tenant platform in Apex. The governors are in place to enforce the efficiency of those transactions that are going through the system. What they do is apply these limitations based on amounts of those resources that you're able to use on a per transaction basis. So the governor limits are not about how much you use Salesforce in an org basis. It doesn't matter whether you have 10,000 users or you have 5 users. The governor limits are being applied per transaction. It's not like because you have 10,000 users, there's this pie that's being split 10,000 ways. Each separate transaction gets its own set of resources that it can use in order to complete that request. Now, if you exceed one of these governors, what happens is that it's a single transaction that'll get rolled back. It's an uncatchable error. A message will be displayed to the end user, basically saying something like, you attempted to do 101 SOQL queries, which is above the limit of 100. And it will basically roll back that transaction, display the error message, and then whoever was the last person to modify either that class or trigger which contain that line of code, they will receive an email with the line number and the specific governor limit resource that was exceeded. Okay? They're subject to change from release to release, so they're often increasing. In my case, I've been working at Salesforce for 4.5 years. The heap space, when I started, the maximum size of the heap space was 1 megabyte. It's now been increased. It went to 2, it went to 3, I think it went to 4, and then it went to 6. So it's gone from, since I've been working here, it's gone from 1 megabyte to 6 megabytes. So they are not something that are set in stone over time. All right. All right, so here are those governor limits. And if we take a look at them, we talked about the bottlenecks of CPU. And the way that we measure that is right here, total number of executed code statements, 200,000. So within a single request, you can execute 200,000 lines of code. Okay? We talked about database. So there's a maximum number of SOQL queries. There's also a separate maximum number of DML operations. In other words, anytime you're doing an insert, an update, delete, something along those lines. There's the issue of the size of the operation. So for instance, within a single transaction, you cannot perform an update on more than 10,000 other records. So the amount of records that you either query from the database or that you are updating or inserting within the database. And then finally, the last thing that you mentioned was memory. So you'll notice that there's the heap space down here, the total heap size, which in a single transaction is 6 megabytes worth of heap. Okay? So these are all the same types of things that you're probably used to writing code. In order to avoid these, either you're finding them in load testing, if you're properly load testing your application and seeing where your performance hits are. In the case of something like the too many SOQL queries or too many database queries, normally what you'll see is that kind of performance graph where the more load you put on the system, the more it tends to hockey stick in terms of response times. Whereas you'd normally need to catch these in a load testing environment, and then if not, they would then, you'd find out in a production environment. We have the governor limits to make sure that they don't bring down the performance of the entire system, because we have the requirement to have a highly performance application server. Okay? All right, so keeping in mind that our governors are applied on a per transaction basis, let's walk through a sample, and then I'd like to quiz you on what you think the answer is. So this is going to involve some math, all right? So first of all, the total number of SOQL queries that can be issued in a single transaction, separate SOQL queries, is 100, okay? So taking a look here, let's say we have a method which is our entry point. It issues 30 SOQL queries. It then also must do some DML because it fires off a trigger. This trigger issues 50 SOQL queries. It then calls this method over here. How many queries could I run? 20, yeah, okay, very good. All right. All right, so 100 minus 80, 20. All right, so let's take a look at another example, slightly more complex. All right, so in this example, we have a method being called, and it fires off 30 SOQL queries. Now, it performs, let's say, 2 DML operations which fire off the same trigger, okay? So this trigger over here gets executed twice, and then over here, how many SOQL queries can we execute?
Minus 30.
Exactly. So we have a problem. So 30 plus 2 times 50 is 130, okay? So a separate firing of our trigger, it's going to execute those 50 SOQL queries twice. So now we have an issue. Okay. Now taking a look at this example, let's take a look at this one. So we call our method, once again our entry point, which kicks off 30 SOQL queries. It then fires off the trigger twice. The trigger has been re-architected so that it now does only 20 queries, which in turn calls method number 2. So how many queries can method number 2 have? Exactly, 15. So what we do is 30 and then 20 times 2, which is going to be 70. And then the key thing to understand over here, method number 2 is going to execute twice because the trigger is going to call it twice. So 30 divided by 2, it can have up to 15 SOQL queries. Okay?